0.035. 0.035. Okay, now we also have this torque. I'm just going to put T sub O, meaning for outer, an outer parameter, right? And that's going to be 800 Newton meters, right? And then at B, we have our radius at B is what? I'm sorry? 20 millimeters. And what would that be in meters? Point zero zero point. So, so exactly. I'm trying to get. Okay, now that makes a difference now in your calculations. Okay. Now, let me go back here and say my. Let me just put radius A rather than putting R outer. I'm just gonna put A because that is 35 millimeters, right? As you can see that diagram, if you look at it closely, they tell us it has a diameter of 35 millimeters. And then we have our torque at B, and I'm going to put torque at A was 800. That's for the overall shaft. And then this is going to be 300 Newton meters. Okay. So what I did typically was I just did a section cut. Okay. This is my cut right here. Because I need to know internally what's going on at B. Okay. And now I chose at B to be counterclockwise. Okay. And this is my 800 Newton meters. So when I do the math, I'm going to get my moment of the torque at B really is negative 800. All that means is that I should have chose this direction. Which makes sense because if you're trying to take this, if this torque is trying to take it counterclockwise, of course this one has to take it clockwise to balance it. Okay, so the shear stress at B would be your T, which we found to be 800, right? Times your radius, which is C, 0.02 meters. And I did the same thing here again. Do you guys see that? I did the same thing again. So who can give me this value, the J, and who can give me the top of the numerator? Does it make sense? Oh, yes. Yes. Yeah, so because that's the that's for the your outer radius. It's not hollow. This particular material is not hollow. Okay. Does that make sense? Yeah. If it's hollow, then you do the difference between the outer and the inner. So in this case, this C, that's a very good question because I want you guys to keep in mind, you may find this later in your studies, this is a solid shaft, right? And let me draw a little bigger. Okay, and this is some centerpiece, the center point right there. That's C, right? So what they're asking, C in this case is, and this is a solid shaft. As I said before, it's a solid shaft. C at this case is 0.3, or let me just put 35 millimeters.
And why would 0.02 be
Yeah, so they want you to find at some location that is not the outer parameter. This is the value that they're talking about here. 20 millimeters. Yeah, this would be T times, exactly. But I just, I know it's a radius, so they just using the P to distinguish between that is an inner radius. That's a radius at some distance from the center, with all the way how can I say this? So this 20 millimeters is a distance somewhere within the parameter of this circular shaft. It's not the outer parameter. That is 35 millimeters. Okay, does that make sense?
Yeah.
Okay. Does that make sense, Mr. J?
Yeah.
Okay. Okay, so that's where this number comes from. But when you want to find your overall polar moment of inertia, you have to take it for the whole shaft, because it's not a hollow piece. It's only one solid piece. And again, that goes back to, you want to design a shaft using 3D printer, but you're using two dissimilar material. Okay, from the centerpiece to 20 millimeters is ABS, and then from the centerpiece all the way to 35 millimeters is your PLA. Okay, but the PLA is what houses the ABS. If that makes sense. Okay. So who can give me some numbers? Top, bottom, it doesn't matter. I'm sorry? 16? That's it, 16? Okay. And then, what about the bottom? .36 times 10 to the negative 6 meters to the fourth. Okay, so what would that value be? Is this too clumsy? Should I erase some of this stuff? Is Mr. L the mayor for the class? Is he the spokesperson? Okay, all right, okay. All right, so what would be when you divide that, what would you get? $67. I think that sounds about right. There you go, megapascal. It's okay. I mean, these things happen. That's why in engineering you gotta have somebody else look at your work. As you can see, I've made some mistakes too. So, this is your this is not your maximum stress. This is this is your shear stress at B. Okay, and it's not the maximum shear stress. Okay, now your maximum shear stress would be at A. Okay, which would be, again, if you take a sectional cut from your overall piece, right? I have 800 going counterclockwise. I have 300, and then so at A, let me just do this. Your moment about A, okay, would typically be some of the moments. I just use this particular formula. I'm choosing clockwise to be positive. That's negative 800 plus 300 minus, because I chose counterclockwise for my M sub A, I'm going to get a negative 500 Newton meters. All that means is that my direction from the get-go should have been this way. That's all that negative means, okay? But now I know the torque really at that location. So this will be my maximum torque times the radius, divide that by J. Okay, and then you have 500 Newton meters times 0.035 meters. And again, I still do this. Okay. I think I need to go back to the other way of doing things. Okay, so who can give us what's going to be in the numerator and what's going to be in the denominator? Okay, that's Newton meter squared. And then what about the denominator? It'd be good practice for you guys, because these some real interesting numbers. To the fourth. Okay, and then we divide the two. Where?
Pi 0325 and the gold.
Yeah, this is 4. Oh, this is. What's up? I'm fixated with 4. I don't know why. That must be a lottery number or something. I don't know. I don't know. Okay. Okay. So what did you guys get? Now did you do that based on 4 or 2? Okay. Megapascal? Okay. Can anyone second that? Okay. Mr. S. Mr. A. Okay. So is it hard? Is it getting simpler, or is it still
Clear up a little bit.
Is it still okay? So we have one clearing up a little bit. Is it a little bit muddy? As someone would say, clear as mud. I'm sorry.
I said I understand it. It was just the 8 was the one that confused me. It makes more sense after.
Okay, now that you know. Okay. And at purpose, I did 9 really and 7, so you can kind of figure out 8. Okay, for your homework. So should I stop this? Should I stop the video? Okay.